Okay, 10.2 guided notes. Thank you for watching those videos on Khan Academy. The reason I had to do this was so this video lesson would not be an hour long. So hopefully you have an understanding of what integrals are watching those 5 videos posted to Google Classroom, and we can kind of move a little bit quickly through the example problems here. So let's start with example number 1. Okay, so it says an automobile travels at a constant rate of 48 miles per hour for 2 hours and 30 minutes. How far does the automobile travel? Alright, so what we can do is, this problem is very similar to example 1 in 10.1. We're just solving for a different part of the equation. So from 10.1, example 1, we were given the velocity average formula, and we said that it equals the change of s over the change in time. Well, we are given the velocity average, right? It tells us it's going at a constant rate of 48 miles per hour, and we're given the change in time. So what we really want to do is we want to solve for our change in s. So if we manipulate this equation, our change in s is going to equal our velocity average times our change in time. Notice I just multiplied both sides by our change in time. We can plug in our velocity average, which is 48 miles per hour, and we're going to multiply that by our change in t, which is 2.5 hours. Those hours will cancel, and then 48 times 2.5 will leave us with 120 miles. Okay, we're going to skip example 2. Again, it's super similar to, it's example 1, just a change of wording a little bit. It's not important. I want to focus right now on the graph to the right of it. Alright, so what we did in example 1, we converted it to a graph here, the problem. So we have, along the y-axis we have the velocity, and along the x-axis we have our time. So we were going at a constant rate of 48 miles per hour over a time interval from 0 to 2.5. So what we have here is, if we find the area of this rectangle, notice we would be taking 48, which would be our length here, and then we would be multiplying it. Your length there would be 2.5, and then this would be 48. So you would have 48 times 2.5, and that would give you, your 120. So basically what we're getting at right here is the area underneath the curve. So area under the curve gives you distance traveled. Okay, this area under the curve that's what we call an integral.